Learn how to construct the unit circle. We're going to start by learning how to do it mathematically, because that's the most important, that you understand how it's created mathematically. And then I'm going to teach you a way to cheat and to do it without understanding any math, but still be able to construct it at a high speed. Okay, so let's start by drawing two 30, 60, 90 triangles. Here's your first one. This is 30 degrees, 60 degrees, and 90. And your second is the same triangle, but now we have 60 down below, 30 up top. So this is what you have already learned. Let me zoom in here to make sure everybody can see it. You have already learned about 30, 60, 90 triangles, possibly in 8th grade, and then again in geometry. Across from the 90-degree angle is called the hypotenuse. And we're going to say r equals 2 for that. R represents the radius. You'll see where this falls into play when we put these triangles into the unit circle in a little bit. Across from 60 degrees is always radical 3. So across from 60 is always radical 3. And across from 30 degrees is always the number 1. The other triangle you have to memorize is the 45. So we have equal legs here. So this is 45 degrees, 45 degrees. And across from the 45s will be the number 1. And your r in this case will be a radical 2. Okay, so now we're going to go over SOHCAHTOA. How many of you heard of SOHCAHTOA before? SOHCAHTOA? Most of us have. So let's go over what you have learned and what we're going to add to that. The sine of an angle, this is not pronounced sin. This is sine, it's abbreviated for sine, is opposite over hypotenuse. Cosine, not cos, is adjacent over hypotenuse. And we're going to do a couple things for tangent. This is not tangent. It is opposite over hypotenuse. Excuse me, opposite over adjacent. But we also often refer to it as being the sine over the cosine. And you can see that because opposite goes with sine, so sine's on top. Adjacent goes with cosine, so cosine is on the bottom. So where do we get SOHCAHTOA from? SOHCA, so, S-O-H, ka, C-A-H, toa, T-O-A. All right, so you're going to repeat the 3 after me, and then we're going to add on to these with 3 new ones you probably have not learned. Okay, sine, cosine, tangent. Okay, so here's the new ones. These are all reciprocals of the top. I'll tell you how to say the words in just a second. For now, just please write them down. Is it hard for anybody to see in back coloring? Okay. Okay, so before I even go over how do we say these words, a lot of students say, I forget which ones are reciprocals. Here's how I remembered. S and C are always opposite. So a common mistake is people want to put cosine with this function. Not true, okay? So here's how you say it. Please say cosecant. And this is just secant. And this is cotangent. And they are the reciprocals of each one of these. Okay, this is a very simple concept, but I think it's important we go over it. Please draw a triangle. Let's name this 3, 4, 5. We'll say this is angle A, B, inside. Let's do a quick review about sine, cosine, and tangent. So sine is opposite over hypotenuse. If I said the sine of angle A, so opposite over hypotenuse, from this angle, what side is opposite? It is 3 over hypotenuse is always opposite of the 90, which is 5. If we said cosine of angle A, this is where students often get confused. They know where angle A is, okay, not hard, and oftentimes they've memorized that it's adjacent over hypotenuse, but what they get confused about is, how do I know which side is adjacent? So this angle, and every angle is always going to be constructed, every angle that we use trig to evaluate, every angle that we use basic trig, sine, cosine, tangent to evaluate, will be constructed by two sides. This angle is constructed by the hypotenuse, and the other side is called the adjacent side. So adjacents can never be the same as the hypotenuse. That means in this case, the adjacent side is side 4, hypotenuse is 5. Let's go over one more. This time let's do cotangent of A. Cotangent is adjacent over opposite. So adjacent is going to be, okay, adjacent of this angle is 4. We just went over that. And opposite is 3. Do not take time to put that into a mixed number if you ever see something like 5/4 or improper 4/3 in this case. Just leave it as a fraction. Okay, we're going to jump to the unit circle. So grab your unit circle, put your first and last name on it, please. My apologies, this should have been copied a little bit better. We're going to start by only focusing. I'm only going to focus, and don't do this on yours. I'm only going to focus on this first quadrant, because if you can get this first quadrant, there are similarities in the remaining 3 sectors that makes it very easy to memorize. So don't do anything unless I ask you to on your paper. Okay, so we're going to start with this. All right, so I want to look at, again, I'm doing this on mine, don't do it on yours. I'm going to go, okay, this from here to here is 90 degrees. And you may be asking, how do I know that? Do you agree that would form a right triangle? Yeah? If I took a circle and I went right through the middle, and assuming this is the middle, right through the middle like a bow's eye, I'd have 90, 90, 90, and 90. That's what makes the 360 degrees of a circle. So if this is 360, and this point cuts this 90 degrees, we call this a sector. It looks like a piece of pizza. It cuts this 90 degrees in half, then what would this angle right here be that I'm coloring in? I'm going to erase it. What would this angle be? 45. Okay. So on your paper, please go to this dotted line and write 45 with a little degree symbol. Now here's what I don't like about this. Sometimes students go, where's the 45? Remember, we're always referring to that inner angle. We write it up here, but it's the inner angle we're referring to. Now let's talk about these points that I'm in a circle, you don't have to. So we have 90 degrees, and then they took this 90 degrees and they split it into, if you want to think about pizza slices, they split it into 3 equal pizza slices called sectors. So if you took 90 degrees, which is this inner angle, and you split it 3 ways equally, each one of these would be worth how many degrees?
30.
So that'd be, this is 30 degrees. Remember, we're talking about the interior angle. Then I add another 30, that make this 60. another 30, this would make this 90. I'm sorry, what? Yeah, remember how the AZ Merit says there's going to be stuff that's unfamiliar to because you haven't learned it yet? Yeah. That's part is unfortunate why they have you take an end of the course test when you haven't learned everything. Okay, so you ready? Here we go. So we're going to look at this triangle right here. Please don't do this because you have to keep yours pretty. I'm looking at this triangle right here. Does everybody see this one? Yeah. And we're going to make it into a triangle. Right now it's a sector. How do you know it's a sector? Because it has this rounded edge like a pizza crust. So here's how we're going to make it a triangle. Just watching. You're going to start at the origin. You go straight out on the line. Once you hit this outside of the circle, you go straight down and you'd create a right triangle. Here's what I'd like you to do. I'd like you to go to your blank piece of paper. Let me find mine. I'm going to turn this upside down. And I'm going to draw this triangle that I have right here. I'd like you to do the same. So it starts here. I'm going to put a dot for that being the inside of the circle. It goes straight out. Hits outside the circle, comes down. We create a 90-degree angle right there. If you are one of the many that go, okay, I know this is 30, but really where's the 30-degree angle? That is the majority when you first start learning this. Remember, this degrees we wrote down always refers to the interior angle, the angle that's closest to the inside of the circle. So this is 30 degrees. If this is 30 and this is 90, and we know a triangle adds up to 180, that leaves this to be a 60-degree angle. Now go back to the triangles you drew at the very beginning. The ones up here. So you're going to help me out. We're going to refer to these, but I'm not going to keep flipping mine up and around, okay? Look at these, please. What is opposite? What length is opposite of 90 degrees? A little bit louder. Anybody? Look at your paper. R equals 2. So let's put a 2 here. Why was it R? Because R is the radius of the circle. So this is 2 when we help construct this 30, 60, 90 triangle. What's opposite of 60 degrees? Square root of 3, radical 3. And what's opposite of 30 degrees? 1. Okay, leave that here. We're going to come back to what you learned 7th, 8th, 9th grade. This is a Cartesian plane, XY axis. And I gave you the point 1, negative 2. That's directions to find a point. So 1 says start at the origin, you're going to go which direction? 1 to the right and down 2. Okay, it's easy for you. You're so accustomed to it, right? These are directions. This direction says go left or right. This direction always says go up or down based on if it's positive or negative. The ordered pairs you see here are also directions. So underneath this, you're going to write this down. They represent, like we think of them as x, y, but now we're going to say it's the cosine of the angle followed by the sine of the angle. And underneath that, in really small, I'm going to write x, comma, y, because that's often how we still think of it. Cosine followed by sine. Several years ago, students said they were having difficulty remembering what goes first. Is it the sine? Is it the cosine? And if you think of TV stations like ABC, NBC, a student made a reference that I've always remembered, and it's helped me remember it. And so, in quotations, write CBS. It's always cosine before sine. Always cosine before sine. CBS. So we're going to find out if you had to give directions to somebody, just like you gave directions to somebody to find the point 1, negative 2, and you knew it was there. Well, if you had to give directions to somebody to find this point, how would you do it? So we're going to start with cosine. Remember, this triangle that I have in yellow is the same as the triangle you have on your paper. Remember that this is the interior angle right here, so let's put a big circle around that. This is your interior angle that you're referring to. So when I say the cosine, I'm referring to the cosine of 30. Okay, look at your paper. What does cosine of an angle represent? What over what? Think of SOHCAHTOA. Cosine is Adjacent over hypotenuse. Okay, so from this angle, what length is adjacent? Remember, adjacent says I help create the angle, but I can't be the hypotenuse, which would mean we're left with what length? Okay, come up here and write radical 3. And cosine is adjacent over hypotenuse. The length of the hypotenuse is 2. Here's your hypotenuse. Okay, now we're going to do the sine. Again, the sine of the interior angle. So sine of 30. Sine of 30. Okay, so sine, first of all, is opposite over adjacent. So opposite of this interior angle is the length 1. And hypotenuse is, again, 2. Okay, let's bump up and do one really similar. Again, you don't have to do this on your paper, just watch. This time I'm going to take a different color so it shows up for you. I'm going to come up and from the origin here, I'm going to go all the way up till I hit the outside of the circle. I'm going to go straight down. And you're going to draw the triangle that you see right now in pink on your paper. This is your interior angle right there. And I'm going to say it many times in the next couple days because it's so confusing for students. We put 60 degrees here on the paper, but that doesn't mean this angle is 60. It means the interior angle is 60, which is really down here. And if you're wondering, why don't we write them down below? Because you see how there's just not much room down below here? So when we say 60 degrees up here, and that means it's 60 degrees from here to this point of the circle, they're referring to the interior angle. So put 60 degrees here. We know we have 90 on the right. Needs to add up to 180 degrees to be a right triangle here, or to be a triangle. So this has to be 30. Okay, what is opposite of 60 degrees? Radical 3 length. What is opposite of 30 degrees? 1. What is opposite of 90 degrees? 2. Cosine before sine. Cosine is adjacent over hypotenuse. Go back into the interior angle. What is adjacent to 60 degrees? Well, I have 2 lengths that create the angle. One of them is adjacent, and it can't be the hypotenuse, which means it is the length 1 over the hypotenuse, which is 2. Okay, now the next is cosine before sine, CBS. So the next is sine. Sine is opposite, so opposite of the interior is radical 3 over the hypotenuse, which is 2. Okay, look how similar this are. See how this yellow triangle and this pink triangle are exactly the same? We've just switched how they're put into the circle. Does everybody see that? Do you see how these are exactly the same? We've just switched them as well. Okay, we have one more triangle to learn. All the way up and back down. Please draw the 45, 45, 90 triangle on your paper. What's opposite of 45 degrees? 1. Opposite of this 45 is 1. What's the hypotenuse, length of hypotenuse? Square root of 2. Now don't get ahead of yourself this time. So I'm looking at this triangle. I need to find the position. Okay, how do I get to this point? So from this interior angle, 45, cosine first. Cosine says adjacent. Again, it's created by 2 lengths. And adjacent can never be the hypotenuse, so it's going to be, don't write this down, it's going to be 1 over the hypotenuse, which is radical 2. And then now we do cosine before sine. Sine, opposite over adjacent. Before writing this down, why can this not be my final answer? Even though I haven't made any math mistakes. Good. we're going to rationalize the denominator. So here's how you do it. You take whatever this is and you multiply it times the top and bottom. So we're still keeping the same value. 1 times the square root of 2 is still the square root of 2. Square root of 2 times the square root of 2. Here's how you do it. 2 times 2 is 4, and the square root of 4 is 2. So this is equivalent, but written mathematically correct, is equivalent to 1 over radical 2. So radical 2 over 2, radical 2 over 2. If you can memorize and understand those, you're doing well. Okay, so now look at this unit circle. I'd like you to take, if you have a highlighter, if you can share it with somebody around you, I'd like you to make a little squiggly line from this dot over to here. Everything we do in the next part will always go back to the x-axis. And it's like I'm making a grid, kind of like a north, south, east, west. Okay? The center, my bullseye is right here. I've separated the circle into 4 equal sectors. I can think of them as quadrant 1, 2, 3, 4. We'll get to that at the very end. Okay, I want you to take your pointer finger and I want you to point to this dot. It is 30 degrees from this dot to go down to the x-axis. It is 30 degrees to go down. There are 3 other points on this circle where it is 30 degrees to either go up or to go down until you hit this line. Take your fingers and where do you find those? Put your fingers on those. Where do you think you find them? There are 3 other places that are also 30 degrees, whether you go up or down until you hit the x-axis. Here's one. Here's another. Here's the third, and here's the fourth. Watch. Do you agree that's 30 degrees? Do you agree this is 30 degrees? Agree 30 degrees? Take exactly what you wrote here, change nothing about it, and please put it into these 3 other locations for ordered pairs. Okay, put your finger on the 45. It's in quadrant 1, 45. Now without writing anything down, please take your fingers and place them where you think there's 3 other dots along this unit circle that are exactly 45 degrees to go up or down until you hit the x-axis, also known as the cosine. Okay, this is like, we think of it as the x because we're used to that, but realize this is really the cosine. So here's 1, here's 2, here's 3, and here's 4. And each one of those 4 positions, you already have one of them done. Please write radical 2 over 2 in both x and y position. Okay, this is 60 degrees to go back down. There are 3 other positions. By this point, you've probably caught on, so let's write those down. This is 1/2 over radical 3 over 2. I'll use a different color so it stands out. Can you raise your hand if you have those done? I don't want to move ahead too fast. Majority of us do. Okay, are you ready? Look back up here, please. Let's go back to what you already know from 7th, 8th, and 9th grade. So if I say the point I have 4 different points here. As it stands, right now I have 3 ordered pairs that have the exact same values in the cosine and the sine position, also known as the x and y is how we think of it. So think of it like this. But what separates these? Because each one of these that I have right now is 1, 2, 1, 2, 1, 2, and 1, 2. But what separates them to give them a different location on the coordinate plane? Positives and negatives, the quadrants. So in this quadrant, what are the x values? What about the y's? What about the x's here? What about the y's? What about x's and y's here? X's and y's here. Positive and. Okay, this is quadrant 1. All x's and y's are positive. Come over to quadrant 2. What are the x's in this position? Okay, the x's, the first, also known as the cosines, are negative. And the sines, like the y's, are positive. Down below, this is quadrant 3. What are the x's, also known as the cosines? And the sines, which are like the y's, are also negative. I bet students ask in the past, does it matter where I put the negative sign? As long as there's only one, it does not matter. This is quadrant 4. You have positive cosines like x values, but negative signs. Okay, we're going to go on to the 4 easiest ones to do after this point. On your paper, you may make dots. I like to refer to these as like the north, south, east, west points. Our unit circle. From the origin to get out to this point, I move 1 unit to the right and I don't go up or down. To get to this top position, I don't go left or right, but I move up 1. To get to the position to the left, I go left 1, and then I do not go up or down. Down below, I don't go left or right, but I do go down 1.